too, right? Water too can move, right, through barriers. So look at this. Look at this example here. We have two compartments. There's a compartment A here, compartment B here. All these blue dots are water molecules, right? Water molecules. What is the tendency of water? Water will move, right, from area of high water concentration, right, to area of low water concentration. Does this make sense? Yep.
Yeah.
That is
Yeah.
what water will do. If I have too much water on one side, water will be, they're going to be bombarding each other, right? It's going to be overcrowded. So they're yearning to leave. They're going to try to move from that area where there's too much water to an area where there's too little water. One thing, let's say if I have too much water on one side, how much solute do you think will be on that side? So if I have a lot of water here, how much solutes, molecules do you think will be on this side? It's going to be decreased, right? Because water will dilute that side, right? Correct? Any area you have too much water, that area will be diluted. Does that make sense?
Yeah.
Good. So the pressure, right? So we can also, so the pressure created, right? The pressure, when you have too much water on one side, the pressure created by having water in stasis in this compartment, right, is what we call hydrostatic pressure. So water in stasis in this compartment A here is going to create what? A pressure gradient. That pressure gradient is going to move in the direction of this arrow, right? It's trying to push water from this side to the other side. Since the pressure created by solutes in a compartment, if you have a lot of solutes in a compartment, the pressure created by those solutes is what we call osmotic pressure. Osmotic pressure. So osmotic pressure. So wherever I have high hydrostatic pressure, right, because of too much water, and the water is diluting solutes in that compartment, you expect to see low osmotic pressure in that compartment. So hydrostatic and osmotic pressure is going to be inversely proportional, right? They are opposite of each other. If I have too much water in one compartment, I have high hydrostatic pressure. Since water is diluting solutes in that compartment, you're going to have what? Low osmotic pressure, right, in that compartment. So this compartment A here, where water is a lot, we have high hydrostatic pressure, which is trying to push water to that compartment B, where water is low. The osmotic pressure here is low. So which means osmotic pressure holds onto water. That's what it does. While hydrostatic pressure pushes water away. So compartment B here, where water is not a lot, I don't have a lot of water in compartment B. So I expect the hydrostatic pressure will be what? It's going to be low in this second compartment. But guess what? Since water is low here, you expect to have a lot of solutes here. It's going to be concentrated here. Since I don't have water here, this area is going to be concentrated, right? So the osmotic pressure will be high on this side, which is trying to pull water, right, to this compartment. Does this make sense? You get this? Awesome.
Because of the osmotic pressure, that is why water is still like plenty at its side. Then the hydrostatic pressure is what pushed a little bit to from the water to the other compartment in the second box.
So you
Compartment
can
B.
see which one. So the second example here, down here, the middle one,
Yeah, the middle one.
right? So for what we did for the first one, right, we have the gradient, but there's no movement of water yet, right? But we know which direction water will move to, correct? But then
Yeah.
from the second example here in the middle, you can see water is already starting to move, right, to this second compartment, right? And what is driving the movement of water from A to B?
Hydrostatic
From
pressure.
is the hydrostatic pressure. Good. So what happens as water start entering this compartment B? What do you think happens now? You can see there's now a smaller force being generated in the opposite direction, right? So there's this leads to these four molecules of water here. Now they're gonna start creating their own hydrostatic pressure, right, in the opposite direction. Does this make sense? Yeah. And then it's gonna get to a point where the forward and the opposite direction force will be the same, equal and opposite. So will you see any further movement of water when this happens in the last box? No, right? Water will stop moving now. Why? Because now you have hydrostatic pressure that are equal and opposite in both in both directions. Does this make sense? They're going to cancel each other out, so water will stop moving. Awesome.
Yeah.
Right. So that's going to be that.